Hello students, good morning. Today I am going to explain the laws of vector addition. Students, to add or subtract two vectors, we have two or more vectors. We have three basic laws of vector addition. The first is triangle law of vector addition, second is parallelogram law of vector addition, and third is polygon law of vector addition. But here in this class I am going to cover the very first law, which is triangle law of vector addition. So let's see how to use triangle law of vector addition to find the resultant of two given vectors. So students, suppose you have been given two vectors, vector A and vector B, and in order to find the resultant of these two vectors according to the triangle law of vector addition, we resolve the given two vectors. We resolve the given two vectors in such a way that they become the two sides of the triangle in same order. In same order means the head of the first vector must be connected with the tail of the second vector. So according to the law, first we'll resolve vector A here and vector B with the same angle here. Now, according to the law, the resultant of these two vectors is the third side of the triangle. Resultant of these two vectors is the third side of the triangle, but in opposite order. If the resultant would be in same order, it will be drawn like this. But since the law says the resultant will be in opposite order, so we will draw the resultant vector R from here. So this will be the resultant vector R. Now what we'll do, we'll here find the horizontal component of vector. So this will be B cos theta. This will be B cos theta. And here this vertical component of vector, this will be B sin theta. So let's name the points O, M, and P. So students, here OM equals to vector A, and MN equals to B cos theta, and OP is the resultant vector R, and NP is B sin theta. So here in triangle ONP, using Pythagoras theorem, in triangle ONP. So according to Pythagoras theorem, OP, square of OP will be equal to square of OM. Square of OM plus square of NP. Square of NP. Now putting the value here, you can see OM will be OM plus MM. So A plus B cos theta. OM will be A plus B cos theta whole square plus NP. NP will be B sin theta. So B sin theta ka whole square. Now solving this, OP is R. So this will be R square, and applying identity A plus B ka whole square here, we will get A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Now R square equals to A square plus, here you can see b square cos square theta, b square sin square theta. So we'll take common of b square and sin square theta plus cos square theta will become 1. So a square plus b square plus 2ab cos theta, and r will be equals to root of a square plus b square plus 2ab cos theta. This is the resultant vector. And now, as you can see, what will be the direction of resultant vector? Let's consider this is alpha. Applying tan theta here, tan theta equals to perpendicular upon base. Perpendicular is b sin theta and base is a plus b cos theta. So, angle of resultant vector. Angle of resultant vector. Tan alpha equals to, here you can see perpendicular b sin theta and a plus b cos theta base. So b sin theta upon a plus b cos theta. This is the angle of resultant vector. Here you can apply different cases here. If the value of theta is 90 here, so cos 90 is 0. So the resultant will be r square equals to root r square equals to a square plus b square. If theta is 0, we'll get r square equals to a plus b ka whole square and etc. That's all for today. Thank you.